This video is on exponent properties. We're going to focus on product of powers, power of a product, and zero power. So, product of powers. This is just when you're multiplying bases together. So remember, the base is the number at the bottom. And we're going to figure out what to do with the exponent, the little number to the top. So, 7 to the power of 2. That just means 7 times 7, multiplied by 7 to the power of 5. So 7 multiplied by itself 5 times. Okay, well, we can combine, and we can say this is 7 to the power of 1, 2, 3, 4, 5, 6, 7. Okay, but when the problem gets longer and more complicated, that's going to take up a lot of room. So the trick is that exponent tells you how many times you're multiplying 7 times itself. So twice, here you're multiplying 7 times itself 5 times. So altogether, you can just add those exponents together, and it'll tell you the total number of times 7's multiplied by itself. So anytime you're multiplying the bases and the bases are the same, you keep the base and you add the exponent, because that tells you the base of 7 is multiplied by itself 2 plus 5, 7 times. Okay, so you can leave it as 7 to the power of 7, or you can multiply it out. In this case, I suggest using a calculator. We get 823,543. All right, so here's just a different way to write that they're multiplied together. And in this case, we have variables instead of numbers. So same thing, y multiplied by itself 5 times y multiplied by itself 3 times. So you're just going to add the total number of times that y is multiplied by itself. So keep the base the same, add the exponents. 5 plus 3 gives us y to the power of 8. That's your answer. So that one is product of powers. Now we're going to look at power of a power. So this is when you have some number raised to a power, and that value is raised to another power. Okay, so this 3 on the outside tells us what's inside the parenthesis needs to be multiplied by itself 3 times. So we can say 5 squared times 5 squared times 5 squared. All right, so now we're back to what we did before. If you multiply the base times itself, all you have to do is add the exponents. So keep the base the same, add the exponents. 2 plus 2 is 4. 4 plus 2 is 6. So 5 to the power of 6. Okay, so I'm going to show you the trick for this. So anytime you have a power raised to a power, all you're going to do is multiply those exponents together. So always keep the base the same. Multiply the exponents 2 times 3, which gives us 5 to the power of 6, which we also had down here. So once you understand how to do it, then you can apply the little trick. And you can also multiply this out. Again, use a calculator because it's an awfully big number. So 15,625. Okay. And again, x to the power of 5 multiplied by itself 4 times. Or you can just multiply the exponents together. Keep the base of x the same, multiply the exponents. 5 times 4 is 20. So x to the power of 20. That one was a little more simple because you didn't have numbers, bases to multiply out. All right, power of a product. So this one is very similar to power of a power, but we have numbers and variables inside the parenthesis all being raised to that exponent. So what this means is 4x squared times 4x squared times 4x squared times 4x squared. Well, then we can go through and multiply. 4 times 4 times 4 times 4, which gives us 256. Then we have the x. Remember, when you're multiplying the base times itself, you add the exponents. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8, so we have x to the 8th. Okay, but again, that could take a while to multiply out. So we're going to go to the trick. Basically, everything inside is going to be raised to the power of 4. And like I said up here, you multiply the exponent inside by the one on the outside. But in this case, it's not just multiplying the exponent of the variables, it's also multiplying the exponent of the number. So currently 4 doesn't have an exponent, but we can raise it to the power of 1. So 4 to the power of 1 multiplied by the 4 on the outside, and you're only multiplying the exponents. Keep the base the same. Always keep the base the same. So we have 4 to the power of 1 times 4 is 4. X to the power of 4 times 2 is 8. And again, we can multiply that out. 4 to the power of 4, I'm going to box that, is 256. X to the power of 8. So a lot more simple than multiplying it out like this, but if you need to do that, go ahead and do that. Okay, over here, we have multiple variables. We have a number and multiple variables. So 3 is to the power of 1. We have x cubed, and y needs to be to the power of 1. Remember, it means how many times you multiply the base times itself. Well, there's just one y there, so it's just times itself once. Okay. Take that 2 on the outside, that exponent on the outside. It's kind of like distributing it, but you're distributing it with the exponents only. So keep the base the same. 3 to the power of 2 times 1 is 2. X, keep the base the same. 2 times 3 gives us 6. Y, 2 times 1 gives us 2. So I'm going to simplify. 3 squared, 3 times 3 is 9. X to the 6th, y to the 2nd. All right, 0 power. This is kind of my favorite one because it's super easy. Okay, anything raised to the power of 0 is equal to the number 1. So 7 to the power of 0 equals the number 1. Super easy. Well, 7 to the power of 1 is 7, but you have 7 to the power of 0 in this case. Okay, so same thing here. If you have 0 on the outside and everything else is inside the parenthesis, it's going to be raised to the power of 1. Because remember, when you have a power raised to another power, you multiply the exponent. So n to the power of 5 times 0 is 0. N to the power of 0. Anything raised to the power of 0 equals the number 1. Okay, that's my favorite because it's so easy. All right, so now let's try some problems that involve some of these properties. All right. So in this one, we're going to do what's inside the parenthesis first because we have a multiplication problem going on inside the parenthesis, and then the whole thing's raised to the power of 3. So let's start by multiplying the numbers. Because remember, 3x squared is the same thing as 3 times x squared. And we can rearrange multiplication so we can multiply the numbers together first. So 3 times 2 is 6. Now we have our x's. Remember, when you're multiplying, the bases are the same, add the exponents. So I'm going to make this x to the power of 1. Always do that so you don't forget it. 2 plus 1 is 3. And this entire thing is raised to the power of 3. So now we have a power raised to another power, so we're going to have to multiply the exponents by the one on the outside. But don't forget that number has to be raised to the power of 1. So keep the base the same. 3 times 1 is 3. X to the power of 3 times 3 is 9. Okay, so we can multiply this out. 6 to the power of 3. 6 times 6 is 36. 36 times 6 is 216. X to the 9th. So the variable part stays the same. It's just multiplying out that 6 to the power of 3. Okay, this one's slightly different because we have power raised to power just for this part, then it's being multiplied by 4n to the second. So we're going to do this part over here first. Simplify that. So I'm going to put 4n squared times. All right, remember, multiply the exponents inside the parenthesis by the one on the outside. So raise 3 to the power of 1, so you don't forget that. We have 3 to the power of 1 times 2 is 2. n to the power of 3 times 2 is 6. I need to simplify that 3 to the second power because these bases are not the same. So when I multiply the numbers, I can't just add the exponents. Remember, it's only if the bases are the same. So I'm going to simplify. 4n squared stays the same times 3 squared. 3 times 3 is 9. N to the power of 6. Okay, now I can multiply the numbers. 4 times 9 gives me 36. Now I'm going to do the variables. Multiplying the bases, and the bases are the same. So keep the base the same, add the exponents. 2 plus 6 is 8. So 36 n to the 8th. All right. Let's try a couple more. So here, we're multiplying everything together. So let's start by multiplying the numbers. 2 times 4 is 8. 8 times 2 is 16. Now again, technically there's multiplication in between the number and the variable, which is why we can rearrange and just multiply the numbers, then go back and multiply the variables. So now we're going to multiply all the x's. Bases are the same, so keep the base the same, add the exponents. This x doesn't have one, but it is to the power of 1, so let's add. 2 plus 3 is 5, 5 plus 1 is 6, so 16x to the power of 6. Right over here, let's start with the numbers. 4 times negative 2 is negative 8. Negative 8 times 3 is negative 24. Okay, we have two different variables, so you're going to do them separate. Any of the variables not raised to an exponent is raised to the power of 1. So this x is technically to the power of 1. This y is to the power of 1, and those all have exponents. So let's start with x. Because you're multiplying bases, you're going to keep the base the same and add the exponent. So this x is to the first, that one's to the second, that one's to the third. So 1 plus 2 is 3, 3 plus 3 is 6. And be very careful, you're just looking at x and not y. Because now we're going to do y. So times y, which means we just plug it on to the end. You don't have to put multiplication. So we're multiplying bases, so we're going to add the exponents, same thing. 3 plus 1 is 4. 4 plus 2 is 6. So negative 24, x to the 6th, y to the 6th. All right, I'm going to give you 6 problems to go ahead and go through, try them out, come back when you're ready for the answers. All right, so first one, let's do what's inside first. So we have 4 times 2 is 8. Y to the 5 plus 4 is 9. All raised to the power of 2. So remember, multiply exponents inside by the one on the outside. Keep the base the same. 1 times 2 is 2. Keep the base of y the same. 9 times 2 is 18. Now I'm going to multiply this out. 8 squared. 8 times 8 is 64. Y to the 18th. Okay, bring down the 6m to the 8th, because we're going to deal with this side first, times, raise 2 to the first power, so we have 2 to the power of 1 times 3 is 3. M to the power of 5 times 3 is 15. I need to simplify this 2 to the third because I can't combine it with the 6 because the bases aren't the same. I can't add exponents unless bases are the same. So 6m to the 8th times 2 to the third. 2 times 2 is 4. 4 times 2 is 8. 8m to the 15th. Okay, now I can multiply. We have 6 times 8, 48. Times m to the, because we're multiplying bases, add the exponents. We have 8 plus 15 gives us 23. So 48m to the 23rd power, or to the power of 23. All right, number 3. This is probably my favorite one because you have a whole bunch of stuff inside that parenthesis and the whole thing's raised to the power of 0, meaning this actually just equals the number 1. Because remember, you're going to multiply all the exponents inside by 0. So everything will just equal 1, and you'll have 1 times 1 times 1 times 1 times 1 times 1, which equals 1. Okay, 4 is very similar. You have this parenthesis in front, 2n to the power of 3l raised to the power of 0. And because when you multiply the exponents by 0, they will all equal 0. So it'd be 2 to the 0, n to the 0, which just equals 1, multiplied by 3n squared. And 1 times 3n squared is just 3n squared. All right, last two. We have 4 times negative 3 gives us negative 12. Negative 12 times 5 is negative 60. If you need to write it out, make sure you write it out. Okay, multiplied by our x. Now we're adding exponents because we're multiplying bases, so keep the base the same. 4 plus 5 is 9. 9 plus 2 is 11. So negative 60, x to the power of 11. And last one. All right, multiply the numbers. 3 times 2 is 6. 6 times negative 4, negative 24. Okay, let's start with x. I'm going to raise this x to the power of 1 and this y to the power of 1 so I don't forget them. So we're multiplying bases, keep the base the same, add the exponents. So starting with x, we have 2 plus 1 is 3. 3 plus 2 is 5. Now we're going to do y. Remember, this means times y, even though I just put the y there. We have 5 plus 3 is 8. 8 plus 1 is 9. So negative 24, x to the 5th, y to the 9th.